the stream. Okay. Are we live? I believe we are live. Excellent. Hello. This is JF Brandon, VP of Sales and Marketing at BotFactory Incorporated. And this here is Aaron. Can you see us? Okay, yeah. This is Aaron McDermott, who just joined us, helping me out on sales and marketing. And this is the first of our many demos that we hope to do over the next forever. We're going to be doing a lot more demos live on YouTube. And we've been wanting to do these kind of things for a while, but now we've actually reached a point where we have some time to put into these kind of things. We really wanted to demonstrate all the cool things we've been making with Squink and just sort of connect and engage with everyone here out around the world. So this is going to be, 30-minute demo. I'm going to be showing all the elements of our new software release. We've graduated from 0.9 to 1.0. Basically, Carlos, our CTO, was basically happy with the sort of redevelopment, the rebuilding of a software architecture, that we reached a certain level of stability that we could go to 1.0. And right now is a time of great change at BotFactory. We have a brand new office. I am in one of the adjacent spaces. It's a boardroom where hopefully it's quiet enough because we're constantly drilling and cutting and shearing and melding and printing and doing all sorts of crazy things in our office, making machines for you. So right now we're in a nice quiet space with Aaron and I, with a machine and a few cameras. Right now I have the machine heated up. I have a circuit ready to print, and yeah, we can go from there. Feel free to post anything on our chat. Aaron and I will respond, and yeah, we hope to go from there. We'd love to take any questions or comments that you have right here. Hopefully I'm coming through okay.
Yeah, can we get a thumbs up if, if you can hear us?
Carlos, hi Carlos. Hopefully we sound okay. Otherwise, let us know, and we'll do our best to make sure this sounds okay. It's the thing about these live streams. When you do the first one, you're never quite sure exactly how good quality we're coming through. We've been doing a few test runs with other people, and we seem to come out okay. Okay, so let's get to the next step. I'm just going to basically run us through the process. I'm going to demonstrate a single pass with the printer, at least the printing part, and then do dispensing and pick and place on a pre-printed part. So let's get to that. Okay, so I'm just going to plug in my microphone because, for a very simple reason, this machine produces a little bit of noise. It's always better to be properly mic'd. At least the printing part, and then do dispensing and pick and place on a pre-printed part. Okay, so let's get started. So right you see on the left is our interface. It's just like the original interface. If you upgrade to the latest version, you'll notice that there's no difference here. But we've changed how the user works through the printing process. Before, we required you to upload different files as you went along. This time, we've actually changed it up, and we've uploaded the files all at once, which allows you to check and see if the files are good, because you might come across an error with the files uploaded, and you wouldn't really know until then. So I'm going to go right to the next step and click Start New Print. Squink is right now connected via Ethernet direct line I'm not using a Wi-Fi connection or a router. I'm doing a direct line connection. First thing the machine asks you is if you're doing a single layer or two-layer board. And it's going to ask you, let's go do a two-layer board for the sake of demonstration. And I'm going to be uploading different files. Now I'm just going to basically uploading a simple circuit that we've had sitting around for a while. And it's going to ask you for all these different files. So Squink works with Gerber files. Gerbers are exported files exported from any kind of electronic CAD tool. All they are essentially bitmap files, I believe. So we can also take image files, provided that they are at a resolution of 508 dpi. That basically means that 508 pixels essentially equals 1 inch on the machine. But any kind of CAD tool will produce Gerber files. They're typically standard in all electronics manufacturing, and you just simply upload the files here instead of having to send them out. So go here, click on upload, and you may not see this, but basically a pop-up screen window with a sort of list of different files, and I'm looking for essentially the Gerber files I'm looking for. So I'm uploading a GTO. It's an outline file. It defines the edges of the board. In manufacturing, the outline file would essentially be where the points at which the board is pulled out from the larger board. So if you're doing multiple designs on a single piece, that's going to be etched and milled and so forth. This is the outline where the edge cuts are going to be done. The bottom copper is equivalent to the bottom side of a board. Usually when you buy a board, it's two-sided. Ours does two-layer boards, one-sided. So the bottom copper is equivalent to that. It's the first layer that's printed. The insulating layer is the insulating layer. It's basically a UV curable ink that we print on top of the printed silver, and then it essentially acts as the insulator between the bottom and top layers. And then the top, basically when you're uploading the insulating layer, it's going to be a drill file, a file that essentially defines where you would be drilling. So there's a bit of a misconception about how exactly we print multi-layer boards without a drill head. So I want you to sort of imagine a machine that essentially prints the inverse of a drilled board. We're printing the insulating layer of UV curable polymer, and we're leaving gaps where the bottom layer and the top layer will be able to connect. So there's actually if you take a look at our YouTube channel, you'll be able to see a demonstration of this process of how we print sort of layer by layer. It's probably the most time-consuming element, and we only have like around 30 minutes to actually do a quick demo. I don't want to bore everyone, so I recommend that you take a look at the multi-layer sort of example to sort of see how we're doing. But we're going to do a run through the whole software, at least with printing one pass of the conductive ink, just to demonstrate that aspect. So we're going to upload the file, and I'm going to upload a .gtl file, and then I'm going to upload the insulating layer. Since this is a single layer file, I don't need to upload the insulating layer. And in fact, what I did earlier was I uploaded a stencil mask, a paste file. And because of the way the machine works, it essentially prints the inverse of whatever you upload. So that's very useful for making solder masks. In future iterations, we're going to be demonstrating that. We're going to have sort of a area where you can upload your mask files, so they can work. I'm going to upload the glue file. The glue file is essentially your dispensing file. It's where you would actually dispense solder paste or conductive glue, what have you, when you actually are, what's the word for it? When you're actually manufacturing things. So we're going to go to that step. So there we go. And then the pick and place file. So the pick and place file is exported as basically a tab separated file, common separated file, an Excel document, a text file. Basically, it's a list of X and Y coordinates of the components, or centroid of the components, the size of the components, the rotation of the components. It's centroid and rotation file. And we were using, I believe we used KiCad to create these files and export it as a .tsv file. We can take .tsv, .csv, etc. And by the way, if you have any questions about whether or not what file you can upload, if you click on here, help button, it will tell you what kind of file. For example, KiCad takes .pos, my bad. Eagle takes .csv, Altium as well. I believe I've used Upverter. Shout out to Upverter. They export a .csv file. All those files are usable as long as it basically has the number of headers with the X, Y coordinates, rotation, footprint size, etc. Squink asks you for information if it's missing stuff. And you can, of course, hand edit this information to make sure that we can upload it. We try to make it as easy as possible in this software to help you reach a point at which this machine can print your files. And we try to stick to what are more or less industry standards. Okay, so let me upload the .tsv file, the centroid and rotation file, and we'll go to the next step. So I'm not printing a top layer because this is not a two-layer file. I'm just printing a single-layer file. I don't need to upload if it's missing files. If I'm just doing a print job, or if I'm just doing a dispensing job or whatever, I can just ignore this stuff. I'm just going to skip these jobs and go to the next step. Okay, at this point, what's going on is our machine is essentially taking all these files and putting them together to display more or less what you're going to see, or at least what it expects to print, manufacture, dispense, and pick and place. You'll notice right now with our machine, all this is actually not going on your local computer. This is actually happening on Squink itself. So there's a computer that acts as a server, and if you notice right here, I'm using essentially a browser, Chrome in this case, to interface with the machine. The net benefit of this is that you can have multiple users on the machine. It's much easier for us to upgrade the product, the software in this case, although you have to approve whether you can update it. It means that we can work across multiple platforms. There's a lot of benefits to doing, let's say, what they call a cloud-based or browser-based interface. And you should see here right now, this is the design I'm going to be printing. So you can see the outline, you can see the blue stuff is the insulating layer, and I can toggle on and off these elements. So if I turn off the outline and the glue, I can see essentially what the machine is going to print in terms of an insulating layer. Had I uploaded a two-layer board, I would have uploaded the drill file and would just basically show the holes, the exposed points. The bottom layer is essentially your trace file, so it's going to print this. Your outline essentially defines where the components are going to be, or not the components are going to be, but just essentially the edge cuts. It's a .gto, so I think it shows the outlines of where the components go. And the paste file is right here. You can almost see it right here. So yeah, I'm happy with this. Critically, all the parts sort of show up in the right spot. They all seem to line up nicely, which is what we're looking for. If they don't, then you simply go back, re-upload the correct file, and go from there. Or you have to edit the file in your CAD tool to make and re-export it, and that happens. Sometimes you just don't place the origin in the right spot. The origin in this case is going to be on the bottom left corner. We're probably going to be doing more live demos, probably where we actually design something from scratch and then upload it to the system and say troubleshoot if we see any issues and sort of show examples of where people make mistakes. Like one problem we commonly come across is the location of the origin and so forth. And we'll probably do some live demos using, we use KiCad and we use Eagle. And I believe those are some of the most common CAD tools out there. Altium, I think, is one of the more popular ones that some of our users have. And hopefully we'll do some examples of making something with Squink using one of these CAD tools. So let's go to the next step. So I have options. I can use standard ink or use advanced ink. I'm using advanced ink because I'm printing with the insulating layer. Insulating layer ink does not work with standard ink. Standard ink only works with photo paper and transparent sheets, and we might get rid of it because printing on paper is not really what most of our customers really want. The advantage of this stuff is just that you don't need heat. Advanced ink needs heat because it's a silver that is sintered by the heat bed at around 80 Celsius, 110 Celsius. And it works, as I said, with our insulating layer to make multiple layer boards. So click there, go to the next step. Okay, so now it's asking me to attach the inkjet head. Okay, so let's go to here. So I'm just going to pan upwards to demonstrate this. And I am going to basically show you how to install the head. So this is the head. It has a DVA, DV25 connector with a rail on the back. Essentially, all I do is I slot it in, and then I plug it in. You don't need to screw in these things. I remember in the 80s having one of these serial port connectors, and the big debate was whether or not you had to screw it in or not. Do you remember those days, Aaron? Are you old enough to remember DVA connectors, serial connectors?
I'm pretty old.
Yeah? Oh, you're my age, I guess. Did it ever occur to you, like, should we screw this in or not? For me, I didn't, and I pissed off my brother so much because he insisted that proper connection wouldn't happen. Rob, if you're watching this, I don't think it's important. You don't need to screw in this part. Long story short, this is how you actually put the head in.
Got a question.
Oh, we do?
From a little bit ago.
Carlos. Hey, Carlos. To answer your question about flexible PMMA. PMMA. Could you look up what PMMA is? I've heard it. It's a material. It's a polymer. I don't know anything about it. I've heard it before. I think it's used in 3D printing. Could you tell me more about?
Acrylic.
It's just an acrylic.
But is it?
It is acrylic. Carlos, is it an acrylic?
That works with the.
Okay, so let me get to the next step. Gotta move along. Okay. So I've attached the inkjet head. Now we're going to the next step. Acrylic base. Yes. So, yes. Yes, you can. I have printed on acrylic.
What is 160? So.
160 Celsius? Yeah, that's acceptable. So, first question I ask for anyone who wants to print with unique materials is, I basically say, will it melt or essentially warp at 110 Celsius? Because if you have a material that's warping or changing or expanding, after you've printed the material, the silver may spread or crack. But the good news for you, Carlos, is that our insulating inks are derived from acrylic. It's a type of acrylic. So yes, you can print with acrylic, but there's, I believe, a large family of acrylic types. So, and of course, the thickness of the material also has an impact. So basically, I have to tell you is experiment, see what happens. And if you have success, we'd love to hear about it because that is something we can add to our library and say, yes, according to so-and-so, they have printed successfully. So try. Not sure if that answers your question or at least is helpful at all. Okay. So I have, I skipped a step without actually explaining what I was doing. So it asked me to put the conductive ink cartridge into the head. This is the conductive ink cartridge. Cartridge care is very useful, critical. One thing I try to do before I put the guy in is, let me just see if you can see this. This is the cartridge. Here's the nozzles. Sorry, this is not a little fuzzy, but I essentially apply a little bit of sort of high-end, these are chemical wipes made by a company called Kimtech. And I just clean the nozzles a little bit to make sure that there's ink flowing through. This is a cartridge that's right out of the fridge. By the way, please refrigerate your cartridges when you are done. And by the way I install this, so I know it's not 100% clear. I will demonstrate for you. So there's two holes here on the back. These two jigs that essentially fit into it, and they hold the pads of this guy onto the pads here. So when I close this, I simply put it in like this, and there we go. All right, so going to the next step. Squink is now asking me click to move to where you want to print. Essentially, if I click here, the machine will move. Let me just make sure that. Oops. That was the tripod moving around. That was not anything else. Okay. Let me just make sure that this thing is stable. Good. Okay. All right. So, essentially, if I want to choose this location, that's great. That's a perfectly good spot. The head is on the substrate. You have to remember that it's going to print a test pattern, and then it's going to go about, I believe, 5 millimeters down. No, a whole 10 millimeters down, and then start printing. So while it's lined up here, it's actually going to be printing about a centimeter below that in this direction towards the thing. If I try to move the machine outside of where it's allowed to print, it's going to be like, you cannot move the head. Very useful, because when it's printing a multi-layer board, this UV cure, this essentially UV lamp, there's a lamp in here, a UV lamp, needs to pass over the ink after it prints. So the limited printing area is actually about a space that's about 3.5 inches, 3.25 inches by about 5 inches. So this is the area which you can actually print with 2-layer boards. With a single layer, no insulating layer, I can print up to 5 by 5 inches, which is almost the entire size of this substrate here. If I go over, it's going to hit this guy. It might hit one of these switches. And you're going to come across, if you somehow manage to move this thing and it hits the switch, this machine will basically just stop printing. But we've spent a lot of time making sure that we indicate to you that you cannot move to that particular spot. So I'm happy with this spot. So I'm going to save location and then click next. Now it's going to ask me to check the nozzles. So there's two buttons here. Nozzle test, which is going to print a pattern that looks like this. And then there's flush nozzles. Flush nozzles basically just jets a bunch of ink on another spot. It's a good way of flushing out any deionized water that you may have deposited in there, or just getting the whole thing to flow in an easy manner. But in this case, I'm just going to do a test pattern, and I'm going to use a Post-it note. Post-it notes are perfect because they have a little bit of glue on there. Kind of hold it down. I'm just going to place it like this. There. And it's going to print in one specific spot. Before, if you're familiar with your machine, before 1.0, we basically could print anywhere. It would print the pattern everywhere. We've changed it around a little bit. It's going to print in the same spot. Specifically, right at the top right corner. Now, arm and you'll see the ink appear under heat. Basically, we haven't really grown up and we're still making invisible ink, more or less. So let me just see if I can see this correctly. There are essentially no gaps. From what I can see right here, there are no missing lines. So maybe my camera. Aha, yes. Okay, so it turns out my MacBook camera is much better. So you will see that this almost entirely matches quite nicely what you see on your software, on the software on the Align page. That's perfect, which means that all the nozzles are operating and they seem to be doing well. Now, if any one of these nozzles was not doing so well, I could just basically turn them off, and it'll tell you which nozzles are not working. They go from 1 all the way to 12. 1 is the highest on the left, 12 is the lowest on the right. And what this machine does is it takes the largest bank or largest set of working nozzles and turns off the rest of them. So if you turn off, I don't know, number 10, for example, it's going to use 1 to 9 to print with, and it's not going to print 11 and 12, even if they are operational. So it does slow down your printing. But if you're missing one nozzle, it shouldn't slow it down by more than 50%. And in situations where you have nozzles, you should probably consider doing a few examples. We have a tutorials page on our website with a cartridge care manual, and I recommend taking a look there and following some of the instructions, which include basically dropping more ink into it, cleaning the nozzles using suction or pumping. Those are great options that typically allow you to resurrect a cartridge if a few nozzles are not working. Okay, so I'm only going to be doing one repetition just to move along. I'm already flowing right past what I said I'd do, half an hour, but I'm just having a lot of fun, I guess. So let me get to the next step, which is reducing this down to 1 pass, and we're going to click Next. Okay, so I'm just going to hit Start Printing. It's processing a file. Now it's waiting to get to heat, and there we go. Let's see if I can zoom in a little bit with this camera. So according to my run statistics, this is going to take about 7 minutes. And I can go into great detail about exactly the process going on right now. This machine is going to run over the entire length of your outline. Whether or not there's ink there, this is just for easier processing on our part. But I can tell you what's going on. Basically, we have an ink that essentially is very fine particles. They're chemically created. They're not ground down from a block of silver. From what I understand, they're created via a chemical process and kept within a solution. Now, these particles are small enough to pass through the nozzles, which are, I believe, as small as... I don't even know. I have to look this information up. But essentially, the machine is basically jets them using a thermal jet technology. We have a small heater that creates a small bubble in this chamber, forcing a controlled amount of ink out onto the bed. The heat, right now we're running at 80 degrees Celsius. So 80 Celsius is what we need to do minimum sintering. If we go any higher, we find that the heat tends to damage the nozzles and shortens the life of the cartridge. So we do a two-step process. When we're printing, we print at 80 Celsius, and then we go to 110 Celsius for 20 minutes to complete the sintering. the particles, when they hit the substrate, the heat essentially causes the carrier fluid to evaporate, and nanoparticle silver and most nanoparticle metals have an interesting property whereby they essentially melt at a lower temperature. So we were actually actively melting silver, which I believe its melting temperature is above 1,000 Celsius, at a tenth or less of the required melting temperature for bulk silver. So this has been sort of this kind of technology, this kind of maturity of this type of method has allowed us to do additive fabrication of circuits rather than subtractive. Because if you recall, circuit boards are essentially, there's a mask made and then on a foil, laminate-backed foil, and then is dipped into a sort of material that boils away or sort of etches away the material that is exposed. Very wasteful, somewhat dangerous, requires a large factory setting. All we're doing right now essentially is using inkjet technology, using existing paper-based inkjet technology with a nanoparticle silver to essentially do additive printing, 3D printed electronics. Oh, thanks, Aaron. So if you can see right here, you can see the actual material just sort of appearing out of nothing. I love it. It's kind of like, it's just like invisible ink. It's magic. What's the phrase? Any sufficiently advanced technology is indistinguishable from magic. Arthur C. Clarke for the win. So you can see the ink is cavitating. Basically, when the liquid hits the substrate, it immediately begins to boil away. And sort of one of the critical tricks that we've been spending a lot of time on is ensuring that the silver remains in a manner interconnected with each itself. And a substantial amount of our research is actually on strategies for printing. The materials themselves are also sort of another critical element of the whole story, but wouldn't believe how much time we spend on the microscope trying to work with what? I mean, each particle, I think, is in the picoliters. It's an incredibly small amount of ink is deposited with each pass at a rate of anywhere from, I think we can get up to 1,000 drops per second. Very fast. Nearly done. So Ben, I have a question. What's the minimum temp? What's the material I'm thinking about? Maybe I'll ask it in the chat. Or Aaron, are you gonna ask him? Okay. Oh. Yeah, it definitely shouldn't melt above that. Okay, so it's done. Yay. Okay, so what's going on now? Well, the red light indicates it's very hot. It's going to get a little bit hotter. In the meanwhile, I'm going to leave this here. Send this backwards. Bottom. Okay, done. Okay, so you see in the software, it says curing. And it's going to do this for 20 minutes. You can kind of see in the sort of gray area on the left under running status how long it's going to run for. And when it's done, it's going to go to the next step. Typically, we do 5 passes to get it conductive. Sometimes you don't need that many. You can do 3 if you have thick traces. If you have very thin, like 10 mil traces, you might want to do 6. And you can always do a quick test after the print, and if it's not working, you can just simply send it back, do another pass, and then do a sintering process again. But in this case, since we're really I already have a pre-printed stuff and I wanted to save you all time, I'm just going to stop this and then go to the next step. And I need to get the insulating ink cartridge, which I have left. Can you get it? It's on my desk. It has... Actually, I know where it is.
Okay.
Give me 1 second. 1 second, people. I need to grab something. Check this out. It's insulating ink. Ran away from me. It's got a little stage fright. Okay. So let's get to the next step, and I'll get printing, and I'll answer your question, Ben. Well, your comment. Silicon is really interesting to us. Okay, so it asked me to... so when I'm done with the cartridge, sorry, I skipped that page. When you're done, good practices to follow. You take your syringe full of deionized water. Do not use tap water. Do not use bottled water. Use deionized water that we provide because that is the safest with this material, with this ink. And I place a small droplet of water onto the ink nozzles. Sometimes it flows right in. Sometimes it doesn't. If it doesn't, just leave it. But you want to get a little bit of ink in there. It prevents unbounded or bounded silver from adhering to the edges of the nozzle so that it could actually block or clog the nozzles. After you've put a little bit of water on the nozzles, you take your tape and you apply it to the surface of the nozzles and put it in the fridge facing downwards towards the ground. That way, you can make sure that no what they call air dams form in the nozzles and restrict flow. You can also put it on its side. That's okay. You just want to make sure that it's not upside down. But this is the ideal situation, ideal orientation. Okay, so we have that going for us. Now Squink is asking me to insert this guy, the insulating ink. Insulating ink does not need to be refrigerated. It can be kept in a cool, dark spot. Don't keep it in your doghouse. Do not keep it in your freezer. Do not keep it anywhere but a drawer. Keep it outside, that's fine. Taping the nozzles, not taping the nozzles, doesn't really matter. Keeping in a container that we provide would be nice if you're taking it on an airplane because it might leak due to air pressure changes. But just keep it in the container and put it somewhere, just not in the fridge. Okay, so go to the next step. Okay, same thing as before. It's going to do a little print test, and I can take a handy dandy Post-it note. I never use these for anything but this, actually. I do a print nozzle test. Is it? Oh, it's really much. Well, due to slight incompetence on my part, it didn't actually print on the surface of the Post-it note. So we're going to do that again. Beautiful. So, same as before. Take a look. Camera runs upside down or backwards, so it's moving it around is not obvious. So you see, every nozzle is jetting, and it matches what we see on our the interface. Now, I find that my insulating ink is at least much more cooperative than my advanced ink, but sometimes you need to clean it. Now, those heaters that create bubbles in the chamber that jet out the material can get covered with this insulating ink. So we recommend that you use a small syringe of IPA, isopropyl alcohol, not the deionized water, important to note, and you apply a little bit on there and let it sort of sit there. I find that immediately applying it and then jetting it doesn't really clean it properly. A little bit and leaving it for 10 minutes seems to do the trick. Cleans the nozzles very nicely. Typically, you shouldn't really have to do this. It happens if you do large, long prints, and you might need to pause it and do a little bit of a clean. That is also relatively rare. I find that the insulating ink is extremely cooperative. So yeah, if I'm doing this print, I am only going to be doing one repetition. I'll probably just do a few passes and then I'll move on to the next step. We're running pretty far behind schedule. So basically you see everything here. The interface basically is asking me for print repetitions and so forth. So we'll go to the next step. One repetition and just go from there. Okay, so machine processing. Okay, now this should be at below 60. I'm going to cheat a little bit. Typically, it should be below 60, but I just want to get moving as quickly as possible. So I'm just going to start a print. It's going to say keep it below 60. I'm just going to skip that. If you had moved your substrate accidentally by like knocking it or moving it, this machine won't be unable to do this step properly because it's going to be essentially thinking the substrate hasn't moved. So it's very important that you tape down your substrate properly. I've used a lot of pieces of what they call Kapton tape, polyimide tape, because it withstands heat very well, sticky enough to hold the substrate down, and it's strong, and it's relatively expensive, I believe. So you see what's going on, right? So let's just take a look at the view. So you can see our UV lamp is essentially printing, or sort of curing the material after it prints. What happens is we print, and the head moves back, basically binds the material. Typically only 2 passes is needed. If you're running low on ink, you might need to do 3 or more. But you should be fine with 2 in this case. And it's going to be printing everything but where the pads need to be exposed. So, going back here, let's turn off everything. This is what it's printing. And this is what exists underneath. So there's going to be areas open for the connections of the LEDs and the battery here. If this is a two-layer board, these would be the vias, more or less. Now, I really need to get moving, so you kind of get the basic idea behind the process. So I'm going to move on to the next step. So I'm just going to stop this and go to the next step. Okay, so it's going to ask me to detach the jet head, and I'm just going to show you a little something that I already made before this meeting. So this is what I made earlier, and oops. This is what I made earlier. Okay, so yeah, you get the basic concept. Oh yeah. 99.999%. I believe I have 90% isopropyl. Do you think you could actually go and ask that question? Carlos, I believe you work with Drexel. I think we sold you a basic unit, so I'm not sure if you can actually print insulating ink with your machine because you don't have the, pardon me? Yeah, just ask them what concentration of the IPA for cleaning. You work with Drexel, right, Carlos? me just move on to the next step while Carlos waits. So I'm detached the head. It's asked me about careful cleaning and so forth. Go to the next step. Now we're going to be attaching the glue head. Okay, so guess what I have here? A glue head. So I'm going to attach this guy right here. Okay, so to answer your question, Carlos, I think we sold you a basic unit, and the difference between our multi-layer PCB printer and what you have is that there is no UV lamp. So the UV lamp is critical for curing the insulating ink. So we have an upgrade. We can certainly sell you this. So if you want to get one of these and you want to print insulating ink, let's talk more. Okay, so what do we have?
Carlos said just the higher the better, but what we're using is
70%.
whatever you get from CVS.
CVS. This is, we're not doing any product placement. No, we're not. We're not sponsored by CVS. Brought to you by CVS. No.
But if CVS wants to talk,
we're open to discussion.
give us a call.
So yeah, 70% is what it says here. This is the stuff we use.
You said the higher the better.
The higher the better. I thought we had 99% stuff. But yeah. Oh yeah, absolutely, Carlos. I will definitely send you a quote for our upgrade. Okay, so going to the next step, I attach the head. Oh, by the way, this is kind of critical that you actually put the head on at this point. You don't swap out heads at different points, because the drivers that drive the motor here are sensitive to changes in voltage. And if the motor is operational and you plug it in, the change in voltage will cause the driver in the back to switch off. It will basically, there's a little tiny breaker on there. So if you find that your machine is, you swapped the head at a different time when we asked you not to, or you swapped it out, let's say at this spot or another spot, and you notice that the motors aren't working, it's not because you broke them. It's probably just because you hit the breaker. So you have to reboot the machine. A customer asked me why his machine was not dispensing, and this was because he installed the head at the wrong time. So please install it when it's safe to do so. Okay, so I have a syringe in here that I placed in earlier. Let me see if I can basically zoom out a little. Excuse me one second while I zoom out. Okay, so let's take a look. What do we got here? This is the head. And basically I've inserted the syringe right here. This is a new type of head that we've changed. We have included a support structure here to better stabilize it under longer, larger dispensed, basically PCBs when you're dispensing. We find that the syringe tends to move a little bit because of the pressure applied. So if you're having issues, give us a call and we'll see what we can do for you. This has been improvement for special cases that you may also be coming across. Okay, so I have inserted the syringe, and often the syringe is full of glue, and you need to move the head up so that you can get the top part of the syringe. For example, this is, do I have? No, I don't have it on me. I thought I had another one on me, but this is the dispensing syringe. I need to, and this is the glue, I need to make sure the head is aligned properly so I can fit the whole thing in there. So that is why we have movement amounts right here. I'm not going to move it because I already have the whole thing in. Now, someone may have asked, how the hell do we make this glue? We have 2-part glues that come with each machine. And here's an example of the glue, which I've got on my hands. This stuff is just an epoxy with silver. So it's extremely safe. Just don't eat it. It's 2-part glue, a filler and a sort of hardener and a resin, I believe. It's the 2 parts of the epoxy. One with the silver and one with the resin. Basically, there's a barrier between the two, and what you do is you take the edge of a table or a squink, and you basically use the edge to break past the side. There's an instruction manual that comes with each machine. It's on the last page of the connection guide, and it shows you with diagrams how to do it. But basically, I mixed it up, cut a corner, filled in the syringe, put it in, and I have 4 hours to work with this material. You can use other materials you want, and we don't care. You can use one-part epoxies. We found that we just weren't able to actually heat it up fast enough, or at least heat it up to the temperature which a one-part epoxy would cure properly. If you have a reflow oven, you can use one-part epoxy, and then after you're done, place it in there. You can use solder paste, but you have to use that on an existing PCB board. We're going to be doing that in another demo because I know a lot of people are using the machine for that. But long story short, we are flexible. You can use any kind of material you want. Okay. Aligning the glue head. So, if you look back down to me. Okay. If you look at this print, you will notice 2 X's, X1 and X2. X1 is going to be for the pick and place head, and X2 is going to be for your dispensing. So I need to do a little bit of handiwork here to align the board, or sorry, align the head to the board. And typically doesn't require no more than a few moments notice and sharp eyes. And there you go. And then once you're happy with the location, what do you think, Aaron? Does X mark the spot?
That's good.
Okay, cool. All right, so location is saved. Click next. Go to the next step. Okay, so before going through the whole process, I'm just going to do a little bit of testing. So I'm going to run a test parameter. So basically I'm testing the parameters. Dot size and load amounts. Let me explain what dot size and load amounts are. Okay, so the way our dispensing system works is it kind of goes down a set amount and then retracts a little bit to ensure that the fluid does not flow out too much. But we don't retract completely backwards. We're not like pressing it down by 1 and then pulling back by 1. Typically what we're going to do is we're going to press down by 1 and then retract by, let's say, 0.8. And that is what essentially these numbers mean. Load amount basically means how much we press, first plunging, and then drop size essentially is the difference backwards. Because it's basically, yeah, it essentially goes back and it goes backwards a little bit less. So if load amount, should be higher than drop size is typically what I find. For fresh mixed 2-part epoxy, 1 and 1 works great. I'm going to run the parameters with this. For other materials, you might need to try more. It really depends on not only what you're dispensing, but also the tip size. So we use Luer lock syringes, so you can try different tip size. We don't care. We're just working right now with what we have, what we supply customers with. So I'm going to run a test parameter, and it's just like our ink testing. It's going to dispense in one specific spot. And well, it didn't dispense anything, so I'm just going to do this little function to get it to extrude just a tiny bit. Now, these numbers are I believe, number of steps. So if I send this all the way to 250, it's going to make almost more than a full rotation, which is quite a lot. So I'm just going to do a set of 10 steps and see what comes out the other end. Yeah, but it's the hardener. It's the resin that's coming out, not the actual ink. You know what I'm going to do? I'm going to go back. I'm going to manually plunge it, and then I'm going to reinsert it. That's what I'm going to do. So the wonderful thing about V 1.0 is that I can go backwards and forwards and things like that. In fact, I don't really need to go backwards. I can actually continue. So.
Did you see Carlos's question about the 4 hours to work this material in these bricks?
Yes. With this material, yes. Do you have... There's other materials you can buy. You can buy 2-part epoxies materials from other people if you want to try something else. But yeah, this material we have is 4 hours. Okay, so kind of want to get it just going right a little bit. Seems like the hardener, the clear fluid that you mix with the silver-loaded resin, was flowing out first because it's more liquid than the other. So I just manually extruded it a little bit just to get it kind of flowing again. I'm just going to increase the movements. Oh, I was not supposed to click that. As I said, wonderful thing about V 1.0, I can go backwards. That was a lot of people are asking about that. If they could actually basically go backwards and forwards. Personally, in the early days, it was very annoying because if you actually made a mistake, you'd have to restart from the beginning. Okay, I'm going to do tip lean. And then I'm going to do a test parameters. Aha! Now it's actually dispensing. Now, the ideal amount that I'm going for is just enough to make it look like a little bit of a Hershey's kiss. Basically what happens is it extrudes a little bit, goes down, drops it, and comes back up. And based on what I'm seeing here, this looks like the right amount. So I'm going to click next. And I'm going to start printing. Okay, let's zoom the camera in so you can see everything. So every few steps, it's going to go back to the sponge and basically clean the nozzles so that any glue that builds up is not going to sort of pass outside the pad. Looking pretty good so far. What do you think? Yeah, that's good. I mean, it's dispensing onto all the pads, which is critical. Yeah, seems to be dispensing just enough. Let's see if I can better zoom in here. I'm not sure if the quality is actually perfect for everyone out there. Okay, there we go. And we're done. Let me just get this screen resized. Oops. And we'll get to the next steps. Okay. So, I mean, this is fine. It dispensed more than enough glue onto all the pads. Spread it a little bit, but that's what we wanted. So, because we're dispensing only 2 bits, 2 passes for each pad, and each component's a 1206, so that's more than enough. I think I can dispense somewhere in the range of 10 to 15 mil droplets. That's about the size of the syringe tip, as I recall. Okay, so let's go to the next steps. So click next. That only took 3 minutes, by the way. For larger boards, that's a huge time saver to dispense more or less automatically, or as I like to say, digital stenciling. Okay, so Squink is telling me it's safe to remove the head, so I pull off the head and put it to the side. Okay. And click next. Okay, now it asks me to attach the pick and place head. So I drop the head down. Okay, now let's make sure I've got the camera right on the head. Okay, so place the head like any other. Take the connector, and this is where the black vacuum tube comes into play. And I basically just snap fits right in there. If it's not connected, you will have no vacuum, and that sucks. Terrible pun. I've been waiting weeks to say that. So long story short, pun intended. Okay, so let's get back down to business. Let me see if I can actually zoom this out a little bit so that you can see the whole part of the process. Okay, so I insert the pick and place head. I like to have this thing lined up because the motor's going to lock when I click next. The motor in here rotates, and as soon as I hit click next, it locks into place. And I like to have this centered because it's going to rotate both left and right. It's nice to have the tube not get in the way. I'm going to do a tray alignment. Okay, so to do the tray, okay, so we have a tray, and that's actually how we pick and place every single component. Let me see if you can actually see everything properly. So this tray is basically going to hold all our components. And essentially, you want to place each component with the pins, pin 1 facing out to the bottom left into each slot. You can see it's basically imaged right here. In order to pick up each component, I need to have the machine aligned to the bottom right corner of slot 16, which is right here. It's that green dot. I know you can't see my cursor, so you have to use my finger. Basically, there's a green dot right there. So what we have to do is click tray alignment, and yet again, we're going to do a little bit of eye work to get that. Well, let's see what the instructions say. Use the controls on the right to move the head so it is aligned with the last slot. The entire tip should be within the slot and should be touching both bottom and right edges. So if this is the corner, you want it within that corner, not aligned on the center, the edge, the corner of that of the tray, but just kind of sitting in there snugly. Okay. Right. So save location, and then I can do something called a test. Basically, before I do a test, basically what's going to happen is it's going to go to each tray slot and hit the corner. An ideal test would see essentially the tip go within the corner, sit right in the center of the corner. So that's why I had to remove those components out right there.
Ben's asking if there are limitations for the number of SMT components you can place.
No, there are no limitations in terms of the number. You just have to do cycles. Essentially, if you have 32 parts, you would not be able to put 32 parts in there, at least because there's only 16 slots. But you can do your first set of components, and then once those are placed, you can put the last set of components. So you'd have to do 2 runs of the same tray. You wouldn't have to re-upload anything. It would upload everything. You just fill up the tray. We'll show you in that process if in the next steps, kind of how what I'm saying there. Okay, so I was reasonably happy with that result, but I think I could do better. I found that the tip was not actually going directly into the center, so I'm going to save that location again after moving it down a little farther. And let's do another test. Yes, that is much better. Yeah, much better. Okay, so I'm happy with this, so I click next. Next, it's going to ask me to align the head to the other X, the top X, X number 1. So what we want to do is, just like before, yeah, that's good. I'm happy with that. So click on next. Place the shield. This is the shield. It's the world's smallest green screen because we're going to be using it as a backdrop for every time we take a photograph of a part and basically determine the edges. I'll explain that in a second. Let me just get the camera re-jiggered. This thing's almost ready to fall over, isn't it? There we go. Okay. Click next. Okay, so what's going to happen next is the camera is going to look for the tip. And what's going on right now is the camera is taking photographs and is looking for the edges and the center of the tip. Once it knows where it is in an XY coordinate, it essentially can be able to take a photograph of a part after it's picked up. And once it finds the edges of the part, it can essentially make adjustments for where the tip is and where the component is. Because think about it, when I'm picking up a component, I may not actually pick it up in the center. And this is true for any pick and place machine. There's going to be the part moving around in the tray or in the packaging, it doesn't matter. So you essentially have to do photographs of the part and the tip to make sure that there's an adjustment for the centroid so that the part is placed correctly. Because we're talking about mils, very fine, sort of precision in terms of placing each component successfully every time. So I'm happy with this. You'll see the circle and the green dot. That basically means it's acquired the tip. If there's a square, it basically means that it's not quite 100% sure where it is. But generally speaking, it's going to do multiple tests, constantly testing to be absolutely sure where the tip is and then average it out. So, but if it wasn't actually finding it properly, I can use the WASD and the R and F to make sure it's located properly. Just to quickly go back to this. So the focal point of the camera is, and the size of this head means that you're just below the top of the head. That should be your focal point. I mean, we demonstrate before I hit camera what a good looking tip would be. Okay, so just make sure this is camera set up. Okay, so tip looked good. So it's going to move the head around a little bit to do tests to make sure that it's finding the tip regardless of where it is. So once that's good, go to the next step. Okay, so let's say I uploaded a file and it had a header. In this case, it's coming from, I believe it's Eagle. I can't remember if it's Eagle or KiCad. It doesn't really remember. I don't really remember. But the original name of the sort of designator, the name of the part that the CAD tool exported was called refdes. That's the header. Squink has no idea what that means. So it asks you to do a little bit of help in terms of translating. So if refdes really meant rotation, you just have to make sure that you tell it that. Otherwise, it's going to get confused. This is also what is helpful. It will actually show you what it's reading right here. So the x equals x, y equals y. Rotation in your header obviously means you meant the rotation. Comment is just the name of the part or what it is. The size, homage, the color, that kind of thing. And footprint is 1206. So I've made all that adjustments, so I click next. Confirmation. Okay. So essentially what we have here is parts, components. So each component is going to have a footprint size. And if I don't have the footprint size correctly defined, it's going to ask me what the heck is that. So if I put a 1206, it's going to ask me for the length and width of these components. Now all these components are 1206s, so it's going to be able to say, okay, every 1206 is going to be 1.5 or 1.6 millimeters by 3.2 millimeters. But if it was a 0603 or anything else, I would have to actually, and it doesn't know what it is, then I'm going to have to provide that information. If you quite literally wrote 1206, as in the word 1206, if it doesn't know what it is, if it doesn't have it in its database, you're going to have to explain it to it. But the good news is that Squink will remember it. So if you're using a lot of common parts, eventually we'll have to do less and less of this. So now I've assumed that I've actually placed all the components and sort of described their sizes. I go to the next step. By the way, it's also very important that you actually get accurate dimensions of the part because we use the footprint information to determine whether or not we picked up the correct components. So you might see failures, and I've had this happen to me, where the part is not placed properly because I didn't put the correct footprint size. Okay, so at this point, I can answer Ben's question. So Ben, if I had uploaded a centroid rotation file with like 32 components, this whole area, this list of components, would be, you'd have to scroll down to see them all. If I clicked on all of them like this, and I clicked on auto load, which basically just starts, slot 0, slot 1, slot 2, slot 3, it will go until it runs out of slots, which is 16. Once I have placed the first set of parts, I can click on auto load again, and it's going to pick up all the components, or load up all the components that are left over. So that's how we use more than 16, how we can actually pick and place more than 16 parts. And the board on our own machine is actually pick and placed using Squink. Squink is technically self-replicating, and in that respect, we are able to kind of build the boards. And each board has more than 100 parts, so we have to do sets of 16 at a time. But as we're running it, we're loading up components into the tray, so it's kind of a process of that can be ongoing. Hope that answers your question. Okay, so I'm going to click on auto load, and ta-da! Okay, so place each component, and I'm just going to slot them in here. Okay, so I want to make sure that, okay, so as I said, pin out. Pin should be the left, and bottom left, if you have pin 1. And yeah, let's hit play. Let's go find the tip. Let's turn on the camera. Okay, so take a look at the camera. So there you go. It takes a photograph. Determine that basically the component was completely aligned properly. So we go to the next step. Fix the component. So it says that the angle is totally fine. So places that component. Now we're going to picking up the resistors. Yes, yes, of course. Okay, ta-da! Okay, let's do a little bit of zoom in. Let's see if I can get this correctly in. I am going to... Okay, let me just see if I can make the adjustments to the camera so that I can... You know what I might do? No, I can't use my computer. We'll see what we can do best with this. Could you hold this? Yes, just like hold it right against the... Okay, so I'm just going to play with the settings to make sure I can actually... Because I don't want the components to fall off. But you can see the components, they're all lined up perfectly fine. I'm just going to see if I can manually... Apologies for the quality. If it looks terrible, I'm sorry. I'm just trying to make sure that I can... There we go. Okay, so... Yeah, unfortunately quality is not the best, but I can do it this way. There we go. So yeah, you can see all the components are placed completely fine. The battery package is too big, and I don't even have one anyway, so I can't pick and place it. But they've placed on all the spots and right where they should be. If I run a cure, I should be able to see this guy cured properly with the components connected to the traces. So you want to bring the camera back. So, ta-da, there we go, that's done. Sorry, did you guys get a good look at that? Looks great, awesome. Thank you, Carlos. Okay, excellent. So let's go to the next step, which is one second, click next. Okay, so I click next. Squink takes its time, and basically what's going to happen is I'm going to run it through a 20-minute heat cycle. You can run it at 10 minutes, it doesn't matter. You just have to cure it for around, I believe, anywhere from 70 to 100 degrees Celsius. And the glue will essentially, will essentially cure. Because it's a two-part epoxy, it will actually cure by itself within 4 hours. But heating it basically accelerates the process. So I start heat. Yeah, we're for 20 minutes because it's relatively fresh. And then what's going to happen is it's going to heat up as hot as it can get, 110 Celsius, and then it's going to run the clock for 20 minutes. And there we go. So that concludes essentially our demo. We printed a circuit and assembled it. If you guys have any more questions, we'd love to take them. This video will be, I believe, posted on our YouTube channel, so you can look at it later. And then we can go from there. If you have any more questions, yeah, just contact us at contact@botfactory.co or through our, basically our online contact form, which I'm going to link to you right now. Yeah, if you guys are interested in buying Squink, we are selling them. We have an online store, and we can send you a quotation if you'd like. If you have any specific technical questions for your machine, we recommend that you contact us at support@botfactory.co, and we can answer your questions there. We're going to be doing more live demos of this. I'm going to let you know if you're a part of our mailing list. I'll be sending out another email informing you of the next live demo we're going to be doing. And yeah, please let us know what you think. Let us know what you think we should be, demoing next. Not sure exactly what we want to do next. We know a lot of people are using our machine for pick and placing existing boards, so we're thinking about doing a demo explaining how that works. And I should be able to do more complex, IC chips and things of that nature. Yeah, really excited to see what else we could think of. There's a lot of applications for Squink. If you think about it, it's rapid prototyping is our sole focus. And we'd like to be able to really demonstrate how it's quite possible to fab a circuit. Instead of having to wait a week or two, you can build it right here. All right, so thanks a lot. Look forward to talking to you guys more, and happy printing. Oh, and...
All the leg.
No, yeah, with all the leg, you're in the shot. Okay. Talk to you later, guys. Have a good day.